couple things that involved a lot of word problems, right? And instead of doing that, there was a little conversion that I want to take you back and show you, which is converting minutes and seconds to degrees. And I want to show you how to do that, and it shouldn't take very long. Um, and then I'm going to break down one part with the formula, and we're going to talk about arc lengths and central angles. And then we're going to save the other part of those formulaic problems for next week, and we'll throw in a few word problems with that next week. But it just felt like a lot to get through in one day, and it's my fault because I forgot to go over the minute and second conversion when we were talking about degree to radian measure the other day. And I know that there's some problems that are going to have it, and you guys should know how to do it, even though it's fairly simple. So I'm going to start with that. And I'm already recording, so I should stop talking and actually start teaching something, or it's going to be a really boring first like 5 minutes of the video. Not that the math makes it all that much more exciting, but still, yeah, I try. I try. So what we're starting with is converting. What we're starting with is me turning the marker part on the pen. So we are converting. Yes, Kevin. Thank you for letting me know, because you'd have to go back and watch the video. Luckily, I haven't barely written anything down. So what we're doing is we're converting minutes and seconds to degrees, right? And it seems like a weird thing to convert, right? Like that degrees shouldn't convert to minutes and seconds. But if you think about degrees, it's all part of a circle, right? Which so are minutes and seconds on a clock when you think about it, right? When you are presented with minutes and seconds, how they'll appear for you is you'll have like a one with a little, I don't know, what do you call that, Mark? A little apostrophe. And what that means is 1 minute, right? So if it was 5 apostrophe, it would be 5 minutes, right? If I have 1 double apostrophe, it equals 1 second, right? And to convert this to degrees, when we're converting it to degrees, a degree, it would be 1/60th equals 1 degree, right? So it's like 1 second equals 1 degree. Does that make sense? Which makes sense when you think about minutes go like the minute hand going around the clock. It's broken into 60 minutes, right? And each one of those would be a degree. 1 second is 1/3600 would equal 1 degree. So a lot of times you'll see things that are written like me touching the wrong button. You'll get like some angle, this angle theta, that say 64 degrees, 32 minutes and 47 seconds, right? Well, your 64 degrees is going to stay the same. And what you're going to do is this is like going 64 plus 32 over 60 plus 47 over 3600. You're just going to add them up, right? And this is definitely calculator math here, right? So 64 is easy, but 32.32 divided by 60, just use your decimal answer. 32 divided by 60. Oh, so it helps if I actually turn the calculator on before I start punching numbers into it. 32 divided by 60 is, yes, that's 3,600, 47 over 3,600. So this would be 64 plus, and you can round these, but I'm going to put for right now 0.5333. Doesn't matter how far I go with it, right? And then I'm going to go 47 divided by 3,600. 47 divided by 3,600. And I'm going to get plus 0.0130. It's 5.5, so I'm just going to put it as 5.6 because it's 5.5555. So I just rounded up. And then on this, I'm just going to go ahead. Once I got that last number, I'm just going to add them all together, and I'd get 0.5333 plus 64, and I get 64.546. I could go forever. 3, 5, and then it's more 5, so I'm just going to write 6. But you get the idea, right? You're just adding these fractions to it to get these partial degrees that add to it. How did I get that 3,600? That is just the conversion. 1 over 3,600 equals 1 degree. So if I have 1 second and I divide it, so in this case I did 47 over 3,600 because that's how many seconds I had. I had 47 seconds. So its conversion rate was 3,600, which is basically 60 times 60, and there's 60 seconds in a minute and 60 minutes in an hour. That's kind of how it works out. Oh, okay. So it's not terribly difficult. I'm not really going to show you a bunch more of those unless you feel like you need to see them. But that felt like a pretty good, just seeing the conversion helps. The main thing to remember is that you add them, right? Like if I'm given 110 degrees, 5 minutes and 12 seconds. This is going to be 110 plus 5 over 60 plus 12 over 3,600. And that's how you would write that out. And this, by the way, your answer is degrees, right? So however you round this down, like if you rounded it to 64.55, it would be 64.55 degrees is what we're getting, because that is what we're converting the minutes and seconds to. Does that make some sense? Is that fairly easy to follow? And I just forgot to show you that when we were doing radians and degrees, and you've got a few of those in the assignment that I made for you now. But we are going to switch gears now, only slightly, and we are going to talk about arc length and how we find the arc length of, well, of an arc, really, right? Of an arc as part of a circle. So there's 3 of us teaching in here, and the light just went out because it didn't see any of us moving. So that's what happens when you're teaching online. It's all from a seated position. Yeah, everything's motion censored at the schools. But I have a big cabinet in front of the motion sensor, so it never sees me. So if I'm in here alone, the light's constantly going out on me. And then I have my big whiteboard that kind of blocks Miss Walters from the motion sensor. And then Mr. Gormson has like screens all around him to was it the shark? Was it the shark you were warning me about? Yes, Kevin? It will tell you how far they want you to do it in WebAssign. It'll tell you to take it to either 100th or 1,000th. So if it says 100th, take it 2 spots. If it says 1,000th, take it 3 spots. But WebAssign will tell you how to round your decimals. So now we are talking about arc length. Maybe if I can actually get my pencil writing again. Like, I think because I keep unplugging my tablet to bring it to my classroom, it comes back and it resets, and then like the pen is super sensitive. And so when we are talking about arc length, I could give you the long drawn out definition that for a circle of radius r, a central angle theta intercepts an arc length s, given by s equals r theta, the length of the circular arc. Or I could just tell you that the length of a circular arc is the formula S equals radius times theta. S indicates arc length, right? R is the radius, and theta is the central angle. And I'll show you all of that as well in a picture that I draw of a circle so that it's not crazy. So to measure the arc length itself, right, we've got radius times theta, and all this came from the radian measure formula. If you remember, the radian measure formula was theta equals S over R, which is arc length over the radius. So this is just, okay, well, we're solving for arc length now. So when we solve this for S, we wind up with this length of the circular arc because we're trying to find the arc now. If we wanted to find the radius, right, we would solve it for R, solve that formula for R, right? And we would get that the radius is the arc length over theta, right? So we can work this in 3 different ways depending on which piece of the equation is missing, right? So let's look at that. One, all of this will always be in radians. Measure in radians. If it's giving it to you in degrees, make sure and convert your degrees to radians, right? So that's an important piece of information. We want to convert to radians. I hate this part of my whiteboard. So we're going to draw a few pictures now. And we're going to talk about, so if I have a circle, let's see how good I do. It's not terrible. It's not great, but it's not terrible. But say I have this Pac-Man right here, And this is a radius of 4, right? Our R equals 4, right? We're saying radius equals 4. Say that this angle right here is the one we're talking about from here to here, and that is 240 degrees, right? And we want to know this arc length, right, that goes around it from here to here. We want to know what S is. We know, whoo, that got big. So I know pieces of this, right? I know that my theta, that central angle, is 240 degrees. It was given to me, right? And I know that R, our radius, equals 4. 4 what? Inches. Call it inches. I don't know. We're saying inches, though. Doesn't matter. It's 4 of whatever unit. And we want to know what S is. It is our missing piece. But all we have to know is that S equals R times theta. And we have R and we have theta. The problem is I have my theta in degrees and I need it in radians, right? So I'm going to have to convert that 240 degrees to radians. And I do that by multiplying times pi over 180, right? 180 degrees. Do you remember that from our conversion? And what it gives me is it gives me 240 pi over 180, which kind of is a really easy conversion because our degrees go away and this 0 is easily gone just by dividing everything by 10. And so I have 24 pi over 18. And however you want to break that down, you can. I know that they're each divisible by 6, right? So this would be 4 pi over 3 radians. And so now I can easily solve our equation because, oops, sorry, that does not go there. I don't know what I was thinking. That did not solve the equation yet. This is 4 pi over 3 radians, right? And so it makes it really easy for us to solve for S because S just equals the radius times our, our theta, right? So it just equals 4 times 4 pi over 3, right? Which gives me 16 pi over 3. And if we could reduce that, we would, but we can't. So it is going to stay at 16 pi over 3. Can it be reduced? Yeah, you could put it in a decimal form. I am not sure what you have to reduce it to. According to my notes here, they're reducing them down to inches. And the way that you would do that is you would just plug 16 pi over 3 into your calculator to get, so if I put in 16 pi, enter, divided by 3, I would get 16.7576 if I round it, inches. So not too difficult. So 16.76 inches. If it's asking you to do it in inches, it might fully accept 16 pi over 3. I just don't know. But it's not like a hard thing. You just plug 16 pi into your calculator and then divide it by 3. Make sure if you're going to hit divided by 3 right away to group that 16 pi first, or hit 16 pi answer and then divide the answer by 3. Or it might screw you up just in the way that you input it. Sometimes you're going to be asked for it in different methods. So what I wanted to do with you guys really quickly before I let you go is to open this up in Delta Math, because there's some actual samples that I can use in Delta Math, even though your assignment is in WebAssign. I like this because I can do them side by side. Granted, it moved you guys all the way to the other side, so you're gonna have to give me a second so I can move this side back over here. And then this side back over here. Man, it really messed me up on this one. Because maybe if I just hit that. No, that didn't work. Not everything's closed. Is it still sharing screen? Yes. Okay, well, I will forget that part. I will just bring another screen over and see if I can make it work. There we go. So if I bring this up in Delta Math, and I plug in arc length, radians, radius, and arc length. Is that what I want? No, this one. When you see it here, you can see that you might be asked for different things. So this is showing a circle 0 has a radius of 24 inches. So we know all our things, right? We've got S equals R theta, right? And so we know certain things. What do we know? We know we have a radius, or R equals 24. We know that the radian measure of angle X, so it is giving us this arc length, this central angle, or theta, is being given to us in the radian measure of the angle that forms an arc whose length is 62 inches. So they're giving us this time that X is 62 inches, and we don't know what that central angle is. And that's the thing that we have to figure out, right? We know what S is and we know what R is. So in this case, we have to figure out what our theta is. So if we want to do that from this formula, just divide R from both sides and we'll get theta equals S over R. And we know what S and R are. S and R are, right? And so we will get 62 over 24, right? And it's going to give us a degree measure, right? This fraction that it's going to create as a degree measure, and we will have to convert it to radian. So 62 divided by 24 is, I'm getting 2.58. It's like 2.583, but this is fine. And then we just have to, well, take that degree measure, that 2.58 degrees, right? Which seems off, man. Doesn't that seem off for the degrees there? S over R, but yeah, I guess so. Um, and that should give us our central angle, but we do have to convert that 2.58 to degrees to pi. Well, it's inches. So hold on, let me see that. 27 inches. Find the length of the arc, whose radius is blah blah blah. Or is it radians? It's like, oh no, that gives us the radian because it wasn't given to us in degrees. It was given to us in. So this is 2.58 rad. 2.588 radians is already in radians. What did I do wrong? Okay, 240. Oh no, 24 theta. Oh, 24 theta, 2.588. Oh, and they just wanted me to round it up to 2.6. I didn't. This one didn't tell me how far to round it. And I guess I was only supposed to round it to a tenth. Was the only problem. So I thought I did the problem wrong. That felt really right to me. But I just didn't round it as low as they wanted me to. They wanted me to round it to 2.6 was all. In WebAssign, it will specifically tell you how far to round it. Delta Math, I don't know if it did on the original equation. It doesn't tell me how far to round it. But in WebAssign, it specifically will tell you how far to round it. So you can have any version of this, right? But as long as you know that one equation and what piece you're looking for, you just solve it for that piece, right? Knowing which piece you have missing. So you'll always be given 2 out of 3. The main thing that you have to remember is if you're given an angle measurement in degrees, you have to convert it to radians before you can do it. But that's the biggest thing right there. Maybe I'll take a few sample problems out of WebAssign that aren't your homework problems, and I'll make you guys a little video or something if you guys seem to be struggling with it. But if you do okay with it, we'll see on that, okay? That is all I have for you today. If you're struggling with anything, I will have tutoring open at 1:30 from 1:30 to 2:30 today. Okay, so there's a link inside Google Classroom now. Just follow that tutoring link, and I'll see you there if you need me. Okay, have a good day, you guys, and congratulations again, Valerie. That was rad. Thank you, Annalise. For sure, Jamila. David, you can wake up and leave now. Yeah, 1:30 to 2:30. All right, cool. See you there.